A 1 kilogram mass is attached to a spring of force constant 600 newtons per meter and rests on a smooth horizontal surface with the other end of the spring tied to wall as shown in the figure. A second mass of 0.5 kilograms slides along the surface towards the first at 3 meters per second. If the masses make a perfectly inelastic collision, then find amplitude and time period of oscillation of combined mass. So, in a perfect inelastic collision, both masses would have the same velocity after the collision and behave like a combined mass. We can apply conservation of momentum here and say that the initial momentum, which is 0.5 kilograms into 3 meters per second, is equal to the final momentum, which is the combined mass 1.5 kilograms into the velocity of the combined mass. Therefore, we get the velocity of the combined mass is equal to 1 meter per second. Now, what are the forces acting on this combined mass? The total force acting on the combined mass would be equal to mass times acceleration, which is mass 1.5 kilograms, and acceleration can be represented as the second derivative of x, displacement, with respect to time. And the only force acting on this is a spring force, which is given by the negative of the spring constant into the displacement. We put the negative sign over here because the force applied by a spring is always opposite to its compression or extension. So this gives us d square x by dt squared is equal to minus 400x. A differential equation of this form has a solution that looks like x as a function of time is equal to a sin omega t plus b cos omega t, where omega square is equal to 400. Now, what is time period of an oscillating body? The time period is given by the time it takes for it to complete a full oscillation, which means omega t has to go from 0 to 2 pi. Therefore, time period is equal to 2 pi by omega. So, time period can be written as 2 pi by the square root of 400 or pi by 10. And we also have to find the amplitude of the combined mass. So at the point of impact, the spring is unextended and therefore it has no energy stored in it. The total energy of the system is stored as the kinetic energy of the combined masses, which is equal to 1 by 2 into the mass into the velocity, and this would be equal to the total energy stored at any point in time. At the extreme position, where amplitude is equal to the displacement of the blocks, there is no kinetic energy and all the energy is stored as a potential energy. And the potential energy is written as 1 by 2 into spring constant into displacement square. And since the displacement is equal to the amplitude, we can write it like this. So then we can calculate this to be the 1 by 2's cancel out. 1.5 by 600 is equal to a square, or a is equal to 1 by 20 meters. Since 1 by 20 meters is 5 centimeters, option A is the correct answer.